Alright, so this is the first problem we'll solve today. You'll see the figure here. This is a car. So we need to actually calculate the drag coefficient of this car. So drag coefficient, you all know that we all know the theory is actually it depends on the design. Anyways, so all the initial conditions are given: 1 atmospheric pressure, 20 degrees centigrade temperature, and the speed is 95 kilometer per hour. And it says, you see, we need to calculate the drag coefficient, and it's to be determined experimentally in a large wind tunnels for a full scale test. The frontal area is given 2.07 meter per square. So you already know the frontal area, how we actually calculate the frontal area. And the force acting on the car in the flow direction is measured 300 newtons. Okay, so that means this 300 newton, this is actually the drag force, right? So now we need to calculate the drag coefficient. So at first we'll write down some assumptions. So for this problem, assumptions are, this is, we'll say, a steady and incompressible flow. So let's say this is steady and incompressible. Okay, steady and compressible. The second assumption is, if you see here, it says we need to just put it in a large wind tunnel. Okay, so we'll assume that the cross section of the wind tunnel is large enough that we can simulate this, like it will be kind of, the flow over the car. Okay, so I'm not writing it here. So the length of the wind tunnel, it should be large enough that we can calculate, or we can do the experiment for the air is just blowing over the car. Okay, and we'll so that's the assumptions. Now what will be the properties? So this is the material here is air. So the air at 1 atmospheric pressure, and you will see the temperature is given 20 degrees centigrade. So 20 degrees centigrade. So in this case, we know the density of the air, it is 1.204 kg per meter cube, right? So this is the density. We need to calculate the drag coefficient. So from this problem, what we can see, what sort of information given, we know the velocity, okay, which is 95 kilometer per hour. We know the frontal area, it is 2.07. We know the drag force, this is 300 newton. Yeah, I think that's the whole information is given. So if we want, then we can convert this velocity kilometer per second to meter per second. So it is quite easy. You already know, just 95 into 1000 over 3600, this is meter per second. Okay, so you can do this. Okay, or so it could be 950 over 36. So that's the velocity, or you can calculate it by using your calculator. So now the formula for the drag force, okay, the drag force is, we know Fd, this is equal CD drag coefficient, the frontal area, density, velocity square over 2, or we're looking for CD drag coefficients, so then it will be 2 times of Fd rho a v square. So substitute all the values here. This is 2 Fd, the drag force is 300 newton, density is 1.204, area, it is given 2.07 meters square, and the velocity we calculated, it is 950 over 36 meter per second. So this is meter per second, and this area is, it is meter square. Okay, and this is kg per meter cube. So if we convert it into like kind of one. Oops. Yeah, just let me go back. Yeah, we can just write 1 Newton, it is equal 1 kg meter per second square. So if we simplify this, we'll get this value is 0.35 CD. So the drag coefficient, this is just 0.35. So yeah, that's the drag coefficient for this problem. It is so easy problem, and I believe you understand this.